Okay, let's try this again. So let us derive the expression for the force of buoyancy on an object due to a fluid that it's submerged in. So to do this, we first imagine that we have a glass of some fluid, and inside this fluid we submerge an object with some volume and some density, and we ask, what is the buoyant force that's acting on this object? Remember that density is defined as mass per unit volume. Okay. So whatever the buoyant force on this object is, it's due to all of the surrounding fluid. And so to figure out what that force is, we conceptualize instead a glass of fluid which has no object in it, and then we imagine a volume of fluid of exactly the same size as the volume of this object. But now, if this has the density of fluid and this also has the density of fluid, well, we can analyze the forces on this thing, and the forces on this are stationary because the fluid is not moving. So we know that there's a force due to gravity acting down, which is equal to the mass of the fluid times gravity, which can be written as density of fluid times volume g. And we also know that there's some unknown buoyant force acting up on the object due to the surrounding fluid, and we also know that the sum of the forces, which is equal to the buoyant force minus the gravitational force, has to be identically zero since the fluid is stationary. Hence, the buoyant force Fb must be equal to the gravitational force Fg of gravity on the fluid, which can be written as rho f v displaced times g. Coming back then to this scenario, we look at the forces that are acting on this object. Again, we have the gravitational force on this object acting down, but now this is equal to mass object times g, which is equal to the density of the object times the same volume displaced times g, and then we have a buoyant force due to the rest of the fluid acting up, which we realize this fluid is the same as this fluid, and hence it has the magnitude rho fluid volume displaced times g. Now if we sum the forces on this object, we get volume displaced times g factors out, divided by rho fluid minus rho object, which is equal to ma.